Welcome back to Infinity Beyond, where we journey into the farthest reaches of space and time to uncover the universe's most profound mysteries. So far, we've explored frozen moons, rogue planets, and icy giants. But tonight, we're traveling further. Beyond stars, beyond galaxies, beyond planets themselves, into the very fabric of the universe. Tonight, we follow a whisper, a cold whisper, a relic of the past that echoes across the cosmos, a ghostly glow that tells the story of everything. This is the cosmic microwave background, or CMB. It's not a planet, not a star, not a thing in the traditional sense. It's a signal, a glow, a pattern of light stretched thin across the entire sky. But it is also one of the most important discoveries in modern science. Let's begin at the beginning, literally. About 13.8 billion years ago, the universe began with the Big Bang. But this wasn't an explosion in space. It was an expansion of space. In the earliest moments, everything was hot, unimaginably so. Particles collided constantly, forming a dense, opaque plasma. Light couldn't travel freely. It bounced endlessly between electrons and protons, like echoes trapped in fog. Then, after about 380,000 years, everything changed. The universe cooled just enough for electrons to combine with protons, forming neutral hydrogen atoms. This moment is called recombination, and it cleared the fog. Suddenly, light could travel freely through space for the first time. That first light, the oldest light in the universe, is what we now observe as the cosmic microwave background. It's a snapshot of the universe when it was just a baby. But here's the extraordinary part. That light is still around today. Stretched by billions of years of cosmic expansion, it now bathes the universe as a faint glow of microwaves. Ultra-cold radiation, just 2.7 Kelvin above absolute zero. It's everywhere, uniform in every direction, and it holds the fingerprints of our cosmic origin. When scientists first detected the CMB in 1965, by accident, using a radio antenna that kept picking up mysterious noise, it confirmed the Big Bang theory. It was like hearing the faint ringing of a bell struck billions of years ago. But the CMB isn't just proof of the Big Bang. It's a treasure map. Tiny fluctuations in its temperature, just millionths of a degree, reveal the seeds of galaxies, clusters, and cosmic structures. These small irregularities, frozen in the CMB, became the scaffolding for everything we see today: stars, planets, even you. By mapping the CMB in exquisite detail, missions like COBE, WMAP, and Planck have created a baby picture of the cosmos. From it, we've learned the age of the universe, its composition, its rate of expansion, and its overall shape. Imagine that, a signal from nearly 14 billion years ago still whispering truths into our telescopes today. Now, here's something mind-bending. The CMB is cold, just a few degrees above absolute zero, but it's not evenly cold. The tiny temperature differences we observe trace quantum fluctuations from the universe's earliest moments, amplified by inflation, a period of exponential expansion that occurred just a fraction of a second after the Big Bang. Those tiny ripples, imprinted on the microwave background, became everything. They grew into stars, galaxies, and cosmic webs stretching across billions of light years. You are, in a very real way, a ripple from that ancient sea. And yet, as elegant as the CMB is, it also presents puzzles. There are anomalies, strange alignments, cold spots, and hemispheric asymmetries that don't quite fit our models. Are they artifacts of observation? Or do they hint at something deeper, perhaps physics beyond the standard model? One of the most curious is the cold spot, a region of the sky that's significantly colder than its surroundings. Some theorists speculate it could be the signature of a cosmic void, or even the imprint of a collision with another universe in a multiverse scenario. It's speculative, yes, but captivating. Let's pause for a moment. Close your eyes and imagine floating in deep space, far from any star. The only light around you isn't from galaxies. It's from the cosmic microwave background. A soft, ancient hum, a whisper older than time. And it's telling you, you are part of something vast. The CMB isn't just a scientific discovery. It's a spiritual one. It connects us to the dawn of time. It reminds us that even in the coldest reaches of space, there is light. There is history. There is meaning. And it challenges us to keep listening. With each new generation of observatories, from balloon-borne experiments to space telescopes, we refine our map of the early universe. We test theories of inflation, dark matter, dark energy. We probe deeper into the physics of creation itself, all from a glow that's just a few degrees above nothing. In the next segment, we'll explore the concept of heat death, the ultimate fate of the universe. If the CMB is the echo of a beginning, what does the final whisper sound like? Can a universe filled with stars and galaxies really end in silence? But that's for later. For now, let's marvel at the simple, profound truth. The coldest light in the universe is also the oldest, and it's still here, quietly filling space with memory.